Okay, this stuff that we're doing now, we're actually going to kind of look at a formula. A formula that sort of a formula of a math, like something in terms of math that we can use to kind of deal with what we're doing. And it's called factorial notation. So this is going to seem, for some of you that don't like algebra and don't like letters with numbers mixed, this is not going to seem nice at first. And the definition's a bit wordy, but it's to kind of write down what it is that is going on. And this is on your formula sheet. So you can take your formula sheet out as well. That would be helpful because I want to show you where this stuff is. This is the unit that has more stuff on the formula sheet than most of the other stuff that we do. And now, wait. All right. This will be a minute. I got to restart everything. I tried to record, but it's not going to work. So. Okay, so I think it's at the top of your formula sheet, top right-hand side where it says probability. It's the very top thing is what we're looking at now, and this is called factorial notation. Okay, and so factorial notation is just a shortened way of writing everything that we've been writing. Doesn't make too much of a difference when we're working with like 6 times 5 times 4 times 3 times 2 times 1. But if you had a bigger number to deal with, it would. So what factorial notation says is that if you have like a number, so n being any number, so n factorial. So like if I have 7 factorial. Okay. What that actually means, what that factorial means is writing out a string of numbers you're going to multiply together that starts with the first number, so n. Then you take 1 away from n, so you're multiplying it to n minus 1. Then you take 2 away from n, so you're multiplying it to n minus 2. And so on until you get down to 1. So with an actual number, what this means is 7 times 6 times 5 times 4 times 3 times 2 times 1. And so then you can use your calculator to find that by typing in 7 times 6 times 5 times 4 times 3 times 2 times 1. The times 1 is pointless, right? It's redundant. So you get 5,040. Or, on your calculator, find the math button on your calculator. Okay. And push the math button. So you're going to push math. Okay. Then you're going to arrow over to probability. So arrow to probability. And then notice that number 4 is an exclamation mark. Now, what I didn't tell you, what you should have done was put the 7 in first. So we'll try that again. So if we go 7, then go math, probability, 4, that's 7 factorial, and you hit enter, and you get 5,040. So now the thing is if you were doing 3 factorial, so 3 times 2 times 1, you can probably either do that in your head or just like push the buttons. Right? There's some of them that it's too much work to go into that menu to use the factorial. So that's just like putting a definition, a name on what we did yesterday. It doesn't work when you have restrictions and stuff. Like you have to kind of look at those ones with restrictions a little bit differently. And then you're basically just writing the number in descending order until you get to 1. Is what that means. So what it also means, though, is that there's different ways that we can write the same number. So I've got 7 factorial here. Right? Actually, so I'm going to do a different one here. So I got Naomi volunteers after school at a daycare center. Each afternoon she lines up her group of children at the fountain to get a drink of water. How many different arrangements of children can Naomi create for the lineup for the water fountain if there's 6 kids in a group? Okay. So she's got 6 kids. So there's 6 ways of organizing those 6 kids. Right? There's 6 ways of putting whoever's first at the fountain, once that person's first. Then there's 5 left to choose from. Then there's 4, then there's 3, then there's 2, then there's 1. So what that would just be read as is 6 factorial. There's no restrictions, and you just want to know how many ways there are of arranging 6 people or 6 things, it's 6 factorial. Or if you want to know how many ways there are of arranging n things, it's n factorial, which will give me 720. There's certain factorials, like 3 factorial, 4 factorial, 5 factorial, and 6 factorial that you pretty much almost have memorized because we use them so much. But because of this definition here, we can manipulate things and write 6 factorial a whole bunch of different ways, right? We can write, so we have like, we wrote it this way with 6 times 5 times 4 times 3 times 2 times 1, which is 6 factorial. Or we can write it as 6 times 5 factorial. Right, because 5 factorial is just 5 times 4 times 3 times 2 times 1. Or we can write it as 6 times 5 times 4 factorial. Because we've got 6 times 5, and then that's 4 factorial. Or we can write it as 6 times 5 times 4 times 3 factorial. 6 times 5 times 4 times 3 times 2 factorial. You wouldn't bother with the one that's 1 factorial, because 1 times 1 is just 1. So we're going to work with today kind of manipulating the notion of what factorial notation is in terms of writing it out algebraically, while at the same time defining what we're going to eventually call a permutation. So at the top of the next page, if you're comfortable, start already. We've got 5 factorial. We can write 5 factorial in 4 different, unique different ways. Like, really, it could be 5, but that 1 factorial one is pointless. So 5 factorial, we can just write it as 5 factorial. Okay, so 5 factorial, that equals 120, or 5 times 4 factorial, which is 5 times 60. No, that's not 5 times 60. 5 times 20. 4 times 3 is 12. No, that's not right. 5 factorial is 70. Look at that. 5 times 24, okay, which gives me 120. So 120 is right. Okay. Or I can do 5 times 4 times 3 factorial, which is 20 times 6, which is 120. Or 5 times 4 times 3 times 2 factorial. So 5 times 4 is 20, times 3 is 60. So that's 60 times 2, or 120. For part B, we just want to fill in the numbers that we need to in order to make the left side equal the right side. So 12 factorial is just equal to 12 times 11 factorial. And we're just completing them, we're not actually evaluating them. 8 factorial, we're missing the 8 times the 7 times 6 factorial. We can also express a string of descending natural numbers that's truncated, right? Like we're missing the times 3 times 3 times 2 times 1 here, so this is showing 6 times 5 times 4. Okay, so 6 factorial, sorry, if I just write this on a different line, 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1. So this part here is missing. which I can write as 3 factorial. So that 6 times 5 times 4 and nothing else, I can write as 6 factorial divided by 3 factorial. And that gives me this. The same thing with that. Does anybody want to make a stab at what this one would be? Go ahead. 50. Yeah, you want to, yeah. I knew what you meant. Yeah, 15 factorial divided by 11 factorial. You figure out which number it stops at, like, or which number, what's the first number that's missing, and that's what you're dividing by, factorial. So then we're going to go the other way. Okay, so we're going to start with a quotient of factorials, and without using a calculator, we're going to evaluate it. Because we've got 10 factorial on top, but we've got 7 factorial as the denominator. So we only need to write it out until we get to 7 factorial. Because if we remember that we can write any number factorial as a product of a string of any numbers, and we don't have to write out 5 times 4 times 3 times 2 times 1, right? We can write it as 5 times 4 factorial. So I can write this as 10 times 9 times 8 times 7 factorial divided by 7 factorial, which gives me 10 times 9, which is 90, times 8, which will give me 720. Does these cancel? Sorry? It just gives you the answer, but if you're asked to show your work, you don't get the answer. But you can check that you're right. You can use your calculator to check that you're right. Okay, 8 factorial divided by 5 factorial times 3 factorial. So that's 8 times 7 times 6 times 5 factorial, okay, divided by 5 factorial, 3 factorial. So we can cancel the 5 factorials. So then we have 8 times 7 times 6 over 3 times 2. Now 3 times 2 is just 6. Okay, so this gives me 8 times 7 times 6 over 6. So my 6's cancel and my answer would be 56. Okay, you guys try those 4 on your own. Take a couple minutes and see how those go. Okay, now things are going to get a little bit more difficult. Okay? Because now what we have to do is we have to be able to manipulate a factorial formula with variables, without numbers. So going back to that definition of a factorial that's on our formula sheet, remember it's on there. What it means is on there. So we're doing the same thing, but with letters, right? We have an unknown. We don't know what number we're starting with. So here we have n factorial equals something times n minus 1 factorial. So that, back to our definition, on this page, n factorial was n times n minus 1 times n minus 2 times n minus 3 and so on. So down here, where we wrote 6 factorial in different ways, this one, like really what I'm doing here is n times n minus 1 factorial. This one is n times n minus 1 times n minus 2 factorial. Right? Because there's n is 6, there's n minus 1, so 6 minus 1 is 5. There's n minus 2, 6 minus 2 is 4. Right? And you want to remember your numbers are always getting smaller. Okay? So these numbers are always getting smaller. 6 times 5 times 4 times 3 factorial is n times n minus 1 times n minus 2 times n minus 3 factorial, and so on. So we want to employ that same methodology, but when we don't have a number that we're starting, when we just have variables. So we have n factorial is equal to something times n minus 1 factorial. So that's got to be n, right? Because that's what's missing off here. It's whatever n is, then you're multiplying it to n minus 1 and n minus 2, and so on down the line. We've got n plus 2 factorial there. What you want to remember when you're doing this is that whatever number you start with, the next one in line is 1 less. Then the next one in line is 1 less than that one. So if I start with n plus 2, I've got to multiply that to n plus 1, right? Because whatever this is 1 less than that. Like if n was 1, this would be 3, and this would be 2. Okay, and then what would come next? N. And then that's what I've got there, n factorial. So that's what's missing. Okay. Wherever you stop, if you're not at 1, you add a factorial. And to write this as a factorial expression, it's just whatever the first number is. That's like whatever it starts with. I've got all the way down to 1, so I go back to my first number, and this just represents n minus 4 factorial. Okay, now we're actually going to use that stuff and do some algebra. Sorry, we'll do some algebra in a second. We're going to look at quotients here. We want to simplify the following expressions. We want to leave the answer in product form where appropriate. So you expand the one that's bigger. Expand the bigger factorial. And if you don't know which one is bigger, make n equal to 1 and plug it in and see. If I didn't know which is bigger, n plus 2 or n. If n is 1, 1 plus 2 is 3, or 1. Right? So that makes the top bigger. So expand the top, or expand the bigger one, until I get to something I can cancel. So if I want to simplify this, I can write this as n plus 2 times n plus 1 times n factorial, right? Because n factorial is what's on the bottom. I expand it until I get to the expression that's equal to my lower number. Because then my n factorials cancel, and my answer is just n plus 2 times n plus 1. And some of you might be able to recognize that where we're going with this after is foiling and then factoring. Okay. With b, which is n minus 2 factorial over n minus 1 factorial, which one of those expressions is bigger? Bottom one? Okay, good. Okay. So I'm going to leave the top as n minus 2 factorial. Then on the bottom, n minus 1 times n minus 2 factorial. Okay, and then I can cancel my n minus 2 factorials. Well, what does my answer look like? Don't answer the other two. Look at that. 1 over n minus 1. Okay, don't forget that we're left with a 1 on the top. Okay, so when you're expanding the bottom and canceling, you're going to end up with 1 over something. So in C, which one am I going to expand? I can't expand something that isn't a factorial. Right? So I have to expand the top. So that becomes n times n minus 1 times n minus 2, and I'm going to stop there and write the factorial because I have enough to cancel my denominator. So what I'm left with, if I cancel my n's and I cancel my n minus 1's, is n minus 2 factorial. Okay. So now we're going to see what we can do with this. So I've got n factorial over n minus 2 factorial. So which one, the top or the bottom, is bigger? Top. Okay. So n times n minus 1 times n minus 2 factorial divided by n minus 2 factorial equals 42. So my n minus 2 factorials cancel. And then I have n times n minus 1 equals 42. And I want to solve for n. That's what I'm doing. So I need to expand this. So n times n is n squared. N times 1, negative 1 is negative n. And then I'm going to minus 42 from both sides. And write 0 on the other side. So then I want two numbers that multiply to negative 42 and add to negative 1. You need, yep, I heard 67. Which one's positive, which one's negative? When your middle number's negative, yeah, okay. So then this is going to be n minus 7 times n plus 6. When you're trying to add to either 1 or negative 1, then the two numbers that you're picking differ by 1. Okay. And then if the number is positive, then the bigger number is positive. If the number is negative, the bigger number is negative. But then this means n minus 7 equals 0. So n equals 7. And n plus 6 equals 0. So n equals negative 6. Take your calculator and try and go negative 6. Oh, no, sorry. Never mind. Well, just try to do negative 6 factorial. Yeah, you need brackets. You need brackets. Okay, yeah, you got an error. You can't take the factorial of a negative number. They're natural numbers, right, which is our counting numbers. And 0 factorial is equals 1, okay, which we haven't got to yet. But, so, you can't go take the factorial of a negative number. So what that means is that we reject that. Okay, it doesn't work. So what I want to do is go back. We go back here. I'm getting a little bit ahead because we do this again tomorrow as well. So n has to be greater than 1. Greater than or equal to 1. Okay. And 0 factorial equals 1. Those are just two things to remember. But we do talk about it again tomorrow. Okay. So you guys try at least the first one. Okay? If you get through that okay, move to the second one, but I think I'm going to end up doing this one with you. So try this one on your own using the same method I used up here. Okay, so the only thing really that's going to end up being different is you're minusing 90 instead of minusing 42. These kinds of questions, this sort of algebra, although this is getting to be standard of excellence question, you should be able to do a question like this one. This one is definitely a standard of excellence. It's a harder one to do because like the pauses tend to throw people off, but you're still expanding it the same way. And you start with the bigger number. So which is my bigger factorial? N plus 4 factorial or N plus 2 factorial? N plus 4. Okay. Okay. Did you see the 6? Ha ha. Okay. Okay. Well, you're kind of right, but yeah, because we don't know what n is. Okay, so n plus 4 times n plus 3 times n plus 2 factorial over n plus 2 factorial, and that equals 6. Okay, so these cancel, and I'm left with n plus 4 times n plus 3 equals 6. Right, and I have to FOIL. I'm just gonna that's kind of written stuff. N plus 4 times n plus 3 equals 6. So n times n is n squared. N times 3 is 3n. 4 times n is 4n. 4 times 3 is 12. And that equals 6. So whenever I have a trinomial, right, which is a degree 2 or a degree 2 polynomial, I get everything onto the left-hand side, make the right-hand side equal 0, and then I factor. So I've got n squared. 3n plus 4n is 7n, and then I need to minus 6 off both sides, so I get 12 minus 6, which is 6. So I want two numbers, then multiply to positive 6, and add to positive 7. Find 6? Yeah. Now, one of the things that makes this one, so n plus 1 times n plus 6. Another little hint about when you're factoring is if the number that you're multiplying to and the number that you're adding to differ by 1, it's always going to be 1 and the last number. We can't now in this situation automatically reject the negative because we don't just have n factorial. We have n plus 4 and n plus 2. So what we need to do is just mentally kind of plug these numbers in for n and see if we get a negative number there to take the factorial of or not, and then that's how we determine if we're going to reject it. So, negative 1 plus 4 factorial gives me 3 factorial, and if I check the bottom, negative 1 plus 2 factorial gives me 1 factorial. So this one I can keep. The negative 1 actually works in that case. But then if I look at the 6, negative 6 plus 4 factorial gives me negative 2 factorial, so I have to reject that. The last example is just, it's similar to questions we did yesterday, but it's just using factorial. So yesterday, like we laid out the lines, right? Like I've got Regina, which is 6 lines, 6 letters. So what we learned yesterday was if we're going to determine the number of permutations, which is just a fancy way of saying arrangements. So arrangements, there's 6 choices for the first letter, 5 for the second, 4, then 3, then 2, then 1, right, which gives me 720. Or I can just write 6 factorial and calculate it. If I have no restrictions and I'm using all of the letters, then I can use factorial. So without writing out the lines, what's a shorter way of finding out the number of arrangements of the words in the letters in Kelowna? 7 factorial. Okay. So 5,040. What, 7 and slash? Exclamation. Well, I mean, it's the same thing. Factorial gets really annoying to say over and over and over again. A whole bunch of times. Okay, any questions about that? Okay, so just some text questions, you guys. Page 82 to 83, numbers 5 to 15. You got about, not quite half an hour, but pretty close. So 25 minutes. So should be able to get through some to at least be able to ask me some questions if you're running into trouble. Sorry, I couldn't.